So our next presenter is Denzil Wasson, and Denzil is responsible for the technical strategy for Sapiens decision suite that is based on the well-known methodology, the decision model, or ZDM, defined by his co-presenter Larry Goldberg in 2009. Larry could not participate in this presentation today, but he is evangelist in Sapiens these days. And as far as I know from presentation of Sapiens at BBC recently, Sapiens has a new implementation and new graphical interface, and actively moving in direction of knowledge representation. And this would be interesting to see what Denzil will present.
Thanks, Jacob. Thank you so much. Thanks everybody for your time today or this evening, wherever you find yourself. Yeah, so you probably know Sapiens Decision as one of the kind of enterprise solutions around decision management. And what we're looking to do essentially is expand the footprint of decision in various ways, because we do see basically similar stuff to all the other presenters over the last couple of days. The low-code, no-code opportunities, the API-based ecosystem that we're in, the cloud-based ecosystem, all those kinds of things we do see as opportunities. The one part that's fundamental is that I didn't really hear much about over the last couple of days, but I guess it's implied, is the event-based architectures. And so what we're going to go through is give you an idea of what we're doing in Sapiens. We're still in the early days on some of these items. So while there is a demo that I could provide, these tools are still fairly primitive, and I'll tell you some of the areas that we know are weak, but certainly would appreciate any feedback from the group. So as we know on Sapiens Decision itself, we've achieved some of our goals, and I think we're all familiar with those goals in the decision management community of explicitly defining the business logic, making it accessible to the stakeholders, be they business users or business analysts, having discrete governance, discrete cadence. So essentially treating business logic like the first-class asset that it should be, which allows a different cadence. Sapiens Decision obviously provides full tool support for the entire lifecycle, for the versioning, for the discrete lifecycle essentially of decisions. And we think that we've empowered the business around business logic. Now, recently we've gone in essentially two separate directions. One is we're providing a new capability called ALE, called Automated Logic Extraction, which allows people to harvest from legacy systems into decision. And then the other one that we're looking at is this low-code, no-code analyst or business-driven solution provisioning space. And today's presentation essentially is about the latter, about the analyst or business-driven low-code, no-code solution provisioning space. So just a little bit of background as to why the thesis that we're basing this on is based around what we're actually doing with decision. So decision in a BPMN world, essentially what we're doing is we're taking what could be potentially vast BPMN definitions or implementations, and we're saying these pieces, these inflection points, are decision logic that potentially requires a different cadence, requires a different ownership, and is not really correctly owned by IT. It should really be owned more by the business and have that separate life cycle. And so essentially what we're doing with decision is we're pulling out pieces of, or chunks of this functionality, if you like, as bespoke decision services. So things that can be used and reused and managed in their own life cycle. And so I guess that's what most of us are doing with our BPMN tools today. So what does it actually mean? Well, what it actually means is that oftentimes the decision management or the business logic is really performing a slave type function within the architecture. So today the du jour seems to be process. Certainly there's a lot of people that don't even have process engines. They're still writing traditional applications, even if they're microservice, single web page applications. But we're still finding that decision's role in the architecture is really, I'll call you when I need some business logic. And so we feel like there could be more to do than that for decision. We feel like decision has a lot of information and has a lot of capabilities, particularly if we consider decision moments or business logic moments as potential event emitters, and start to think of decision in terms of decision knows when to emit particular events. And so we think that there's an opportunity for business logic to play a bigger role, and hence the evolution of our knowledge-driven decision management. And so what we're looking to do is essentially empower the business more than we have. So we've had great success with a lot of our customers in terms of getting the analyst group, and it's not really the end business user. What we find is this really elevates the role of the business analyst, or in my mind, makes the business analyst do what they should have been doing all along, which is a much more empowered user that's closer to the business, but still leverages IT for certain things. And we'll talk a little bit about what those certain things are later. And so we're looking for the same kinds of things that we've achieved in our business logic with decision. We're looking for explicit definition. You know, I've been in IT for going on 35 years, and I can't tell you how many times I feel like A, I've written the same thing. B, we've built requirements, built models around requirements, design models, turned it all essentially into code, and then started the same thing all over again. So I'm really happy that I discovered IT early in my life, but I don't think it's the most efficient use of our time. And so the fact that we're doing all that definition and then throwing it away as we go through the life cycle seems crazy. So we're trying to address that explicit definition. Stakeholder accessibility. Some of the problems with models, and even with naming, you know, when people say low code, no code, the business says that's something for IT. The problem with no and low code is the word code. So it should be something different. And so we're looking for an explicit definition that is accessible by the stakeholder. Who is the stakeholder? Well, it really depends on the context. And so we think the primary stakeholder for the business processes and business logic is going to be the business analyst. But as we go through this, I think you'll see that there are different contexts that a particular model could be viewed in. And one of them could absolutely be an IT context, that the IT says, these are my models because they represent a binding of your models to my technology. And so we think that the same kind of approach could be used for multiple stakeholders. We'd like it to be governed and versioned, much like we do with decision. So we already know how to manage those, how to push them through life cycles, how to version them, how to make them immutable when they're out in production. So can we do the same kinds of things? And then of course, what we'd like is the no/low code kind of situation. Now, pragmatically, you know, done a lot of coding in my own lifetime, still do occasionally. And I really think that there is a point of diminishing returns when we get to no code. And that point of diminishing returns is either compromise on the part of the business, or it is essentially having some kind of capability that a developer could use some traditional things, some traditional language to extend some capability. And so pragmatically, we feel that being somewhere in that 80–90% is potentially good enough for where we're at. And so what we're going to be looking at essentially is saying what we'd like to do is we would like to do for use cases what we've done for business logic. So we would like to take use cases and define them in such a way that we achieve all of these goals. Okay, and what's interesting is that a lot of the presentations that have come before in the last couple of days have touched on various aspects of what we're going to go through now. And so I'm actually quite happy about that, because there's a lot less foundational effort that I need to put in to be able to get people to see what I'm presenting. So the very first thing, we heard about a concept model. So I didn't plan that presentation. It was fantastic that we heard about a concept model. And a concept model is essentially an Uber vocabulary or an Uber domain model. Okay. And so what we do with a concept model essentially is we define at a metadata level the elements within our domain and the decision points within our domain. And so looking through this model, we'll just go quickly, I'll iterate through the notation several times so that we can see what they are. The red oval in the middle is the focus. So the tool essentially is saying, this is the guy that you're looking at, and he's showing some of his neighbors. The green one essentially says there's more neighbors, because what we're looking at is a snippet of a concept model. A real world concept model is huge and is used in multiple contexts. And I'll show you how that occurs in a minute. Well, what this gives us is a structural representation of our domain. Each of these items, so for example, a question, we saw earlier where we were having essentially screens driven by a decision model. Very similar concept where here the question is all of the metadata about a question that we would typically capture to build a system. So that question, for example, says, here's the question, here's the text. Maybe there's another node associated with the internationalized text. It says, here's what an acceptable answer looks like. Here's the formatting of an answer. Here's the, if I'm going to put it on a screen, here's what I'd like it to be called. So essentially all of the information that we would capture when analyzing and designing the solution goes into this model. Okay, so we're preserving this as essentially a concept model that represents complete knowledge of this particular domain. Now, what's interesting is this is captured as a graph model rather than a relational model. And so this is an implied schemaless model. Schemas can be versioned, and it's an implied many-to-many because many-to-many is an inflection point that we've all come across where we think something's one-to-many and then tomorrow it becomes many-to-many. And so graph by its nature implies many-to-many, implies schemaless, and implies versioning of the schemas. So what we're able to do then essentially is build out a model that looks like this. We have some specialized nodes called decision nodes. And in our particular model, we have two kinds of decision nodes. One that is within a use case, and then one that ends a use case or an inter use case decision. And essentially what we say is that this model provides the fundamental programming constructs that we need, being sequence, so traversing the nodes in a certain order. The existence of nodes means they can traverse. Selection, the fact that I have decision nodes within the model, placed in relation to the items that they make decisions on, allows me to do selection. And then iteration, as I said, the associations are implied many-to-many. So the fact that for a loan application, there are n number of questions mean that n number of questions essentially need to be generated. So this meta model gives us enough information to generate not only UIs, but it gives us enough information to also generate bespoke knowledge services. So essentially what we do is we pass this through a generation capability and we get knowledge services for this particular knowledge concept model. Okay. And so what's the use of that? Well, now we have this concept model where we've preserved all our knowledge about the domain, and we have a set of services that are able to manage instances within this domain. So the next point, the next goal then is to say, let's curate our knowledge model. And so curation is essentially hydrating the model with data through those bespoke services. And so the important thing about curation is you can see, for example, the question node has now become questions 1 through n, may have multiple decisions associated with them, and those might be data acceptance decisions as an example. There's multiple events that are occurring, and each of these nodes are shown here in the gray could have multiple different instances. So thousands of millions of instances, potentially lots of different combinations. You could imagine the case where this personal loan application is occurring within a particular jurisdiction, if jurisdiction were on our model, whereas this is another jurisdiction. And so maybe the questions are different. Half of them are reused, but the questions are different. And so this is a very natural way to reflect the actual business data that we need to execute the use case. What's interesting as well is it also gives us the point in time that we need to be invoking certain decisions by traversing the graph. And it also gives us the data that we would need to store if we were actually going to save a transaction, let's say, because we know what the answers look like. And so we're able to generate not only the API to manage these things, but if you did a personal loan application, we would know what the API would need to look like to be able to save your particular application. Now, obviously, the framework includes internally things around versioning and effective dating automatically, so that those best practices that we've baked into our decision practices are automatically built into this environment. And so essentially what we have now is we've got the meta model, which is all of the information we know about the domain. We've hydrated it with actual data. Now, the challenge is that this particular model, as I said, is a snippet of a real-world knowledge graph. A real-world knowledge graph is potentially huge. And so the analogy I like to think of is, let's say I had Google's graphical information system data, and I'm just looking at all this data. It's not much use to me, but when I say to Google, hey, I'm looking to go from this place to this place, what I get is a particular route through their GIS, or potentially more than one route through their GIS. And that's what we're calling use cases. Those are where the use cases come in. And so what we find is that there's a meta model around use cases. And so we find that this particular thing essentially gives us the navigation through the model. And so we heard an earlier presenter talk about context. Context is key. And so the way that we begin a use case is we start with a context. And there's two contexts that we can potentially do. One is we could say, I'm looking for a particular concept or set of concepts. Remember, these associations are implied many-to-many. So I'm looking for either any of these concepts to arise, or I'm looking, and in most instances, I'm looking for a particular instance of a concept to be arising as an event. From that point, I have a context and I can go off and do either individual use cases and steps, or I can do a use case flow, which is just an aggregation of use cases. And so essentially what we've gotten then is between the models. Now this model would be much more intuitive. Even though the data may be stored like this, building this model, which would be much more intuitive if it was a BPMN or DMN type model that says this is the sequence of events that we're going to go through. And so right now, the way that this model is built is the same as the way the domain model is built, and that's a serious weakness for us. So we think that this would be more of a traditional flow type model. And so essentially what you're doing, combining the curated and the use case model, is you're saying, listen, when this particular event occurs, when somebody's asking for a request, I'd like you to navigate in this way through the model. If they came with a different use case, I could reuse some of the same nodes, but I might go in a different order. So for example, use case one, I'm going to go in and may say, I'm going to render a screen, I'm going to ask all the questions, I'm going to apply the decisions. And then when they say, and then I'm going to essentially say, yes, your application's good from, let's say, a data acceptance point of view. Whereas a personal submission might come along and say, well, I've got a personal loan submission. I'm going to take a personal loan, and I might have off here the existing transaction with the answers that I'm going to hand off to determine whether I'm going to provide the loan or not, whether I'm going to give the person the loan. And so what we have between those three models essentially is the ability to conduct use cases and to perform decisions where they're appropriate. What we've also done, there's a couple of fundamentals that we've gotten here. You know, we know that there's a challenge of, you know, I need your glossary and your API definitions and my screen definitions and the database definitions to all kind of match or we map them all together. And in my opinion, in cloud-based API ecosystem, the new brittleness, the new legacy is going to be the hordes and hordes of mapping code. And so here what we've done essentially is we're able to use the same vocabulary, whether we're managing the underlying resource, whether we're providing the API, or we're providing the screen for the end user. So we're generating all of that off of the same model. And so essentially what we've done now is we've recognized a pattern that says what we find is when a use case occurs, there's generally a pattern of an originating event, a use case that involves a use case map, that involves a knowledge graph, and involves one or more decisions. And then we usually at the end of that have some sort of decision or business logic that says, are you done? Do I need to get back in there? Is it okay? Or does it need to be routed in some particular way? So there could be n number of outputs here. And essentially these are events. And so what we're finding is that decision now essentially is starting to perform a different role within the architecture. So we're explicitly saying decision is the director within the architecture. And what we're doing is we're pulling out snippets or these micro use cases, micro processes. I've heard them called nano processes or nano use cases, and eventually pulling these out and creating for ourselves a menu of event-driven microprocesses that that contain externalized business logic, and the coordination of who cares about which events and what events to emit is done via business logic. So it's controlled by the business. And so you essentially end up saying that we've got these capabilities that are sitting out there, a whole menu of them with the events. And what we're seeing now is that the business essentially is able to own, similar to how they do the business logic, the when, what, who, how, why, and where. IT owns the implementation. Okay, so what's important is that IT has to give us the technology binding. So in our case, those models are generating through a specific code generation capability to get a particular implementation. And so that is IT's role, is to say, these models are going to be implemented in this way. They also provide all the surrounding context in terms of security and all those reliability, accessibility, et cetera, et cetera. And we do believe, so in our particular framework, we do believe that inside of the use cases, there's extension points where traditional IT could do some things if they need to. Of course, the key element being that they constrain themselves to the visibility of the interior of that use case, because if they go outside of it, they potentially are breaking the encapsulation that we've achieved.
Denzil, I want to ask a question while you're on this slide.
Sure.
So you said that IT owns implementation and provides technology binding.
Correct.
But what if technology binding by itself is business logic? Why does it belong to IT?
So that's a very good question. And so I didn't want to go too far today, but in our opinion, another one of those knowledge models provides the technology binding. There are technology models. And so we've heard about, for example, SVBR, where we talk about nouns and verbs. And so these kinds of things are really important, because when I say, oh, I want to save my loan application, the loan application is perfectly defined in the knowledge model. What does save mean? So what I'm looking for is a use case within a technology binding knowledge model that says, I have a save event and I have this knowledge construct to save. Give me a binding. And at that point, that binding is then a data configuration within the same kind of model that says, oh, here's the endpoint, here's the API, or it could be a binding that says, here's how you generate it. You use this framework, you use these templates to go and generate it. And so that technology binding, while we see right now, technologists are really kind of saying, well, I can be a knowledge-driven application. So I can go to knowledge to say, tell me which questions to ask, tell me which forms to fill out, what question do I need to ask today versus tomorrow? And similar to how they use decision, what we see in the future is that those bindings themselves will be knowledge models as well. That essentially it's just an event. When you say, I'm done with this, validate it for me, tooling validates, and then you say, please generate this for me. The tooling at that point could go to a knowledge model that is the technologist binding and say, I'm looking to save this resource. Give me a binding instruction. Does that answer the question?
Yes, thank you.
Yeah. So I didn't want to overload with too many models, but that's exactly the idea, is that would just be a different knowledge model, a different stakeholder modeling their domain. And then the tooling could pick up that the event is the customer's asking me to generate a binding to save this particular resource. How do I do that? And in that case, the business that's owning the how is going to be IT versus the business. But business still has to give us these things in terms of hosting, accessibility, reliability, security, scalability, et cetera, as well as a bespoke technology binding that they prefer. Okay. And so, of course, everything works well in green fields and in the lab, but the real problem is when it comes to change. And so I think we've all been in this situation. We live it every day, where we kind of say, okay, so let's introduce a change. So there's in the financial services, there's this know your customer requirement that says, before you give somebody money or open up accounts or accept money from them, you need to know certain things about them. Okay, and so the question is, when I'm in a real world situation and I've got these BPMNs and frankly, you know, what I've heard in this session is my own, what I've heard in these sessions is my own experience too, because frankly, what we actually have is we actually have a bunch of code that has a somewhat loose fidelity to the BPMN that the business thinks it does. And as we start to get into it, if we start to analyze at this point, we essentially do another impact analysis when we get to the actual code. And so there's fundamental problems there when my artifact that I'm managed against doesn't have good fidelity to the artifact that's executing. So am I doing the right impact analysis? What do I do? How do I test it? If I'm changing this, and so the fact that there isn't this strict encapsulation, am I testing a piece that's this big? Am I testing a piece that's this big? And so we really find ourselves in a highly variable situation, and that introduced risk. And so instead, what we'd like to do, and this is really just leveraging the event-based nature of what we've built so far. So essentially what we'd like to do is say, oh, well, actually what we're going to do is change the wiring endpoints. Now, people who have been around a while might remember a long while back in component-based development, Microsoft had an architecture called SCA, which was a similar kind of concept. But all of the components were hand-built, were handwritten. And so essentially what we're saying is we think that by modeling things this way and treating some of those specifications in a similar fashion to how we treat business logic, we think that being able to build these things in the low-code, no-code environment, we could do in an accelerated fashion. And then we're just rewiring. So previously, Loan Applique went straight into conduct the approval. What we've done is defined a new use case. It may well imply some new concepts on the model. If we need new concepts, we can add them. It may just be some new questions, a new section of questions that we're putting onto the application, in which case that's just data. We're not even going to have new services. We can just add data to our questions. But essentially, we reach the end of the point. We can test this individual unit. We can wire it in. These other units are essentially trusted, and so they can be individually tested and understood. And then we could just run a scenario test across the entire architecture. And so we're seeing this pattern kind of repeat in terms of how our code is built. And the important thing is that these events essentially are conclusions of business logic. And so what we'll see is that these events essentially have the events that come out of the business logic at the end of use cases essentially have two general characteristics. One is they're directing you to go back to the knowledge graph with a new context, in which case you're going to go to the use case graph. You're going to say, this is my context, and it's going to say, this is my context, and here's my use case, because I know what I want to do. I know that I'm the guy that conducts an approval review. Here's my context, and knowledge tells you what to do. Or the other one is where we're essentially saying, hey, I need to save this. So there is a vocabulary of verbs that essentially relate to system functions that say, I need to save this, I need to post this, I need to email this. And so that vocabulary essentially is where technology will provide us the binding as well that says, oh, to save this, you're going to invoke that service and call it. And so what we think we've ended up with essentially is a similar thing that we do with business logic, and allows a rapid change. We believe that business analysts will be able to be taught to use these kind of environments. I do think that the process side needs work, because the use case models are hard for people to imagine at a metadata level. So a flow type tool like a DMN type tooling, I think makes more sense to be able to define use cases. But the couple of side effects that we think are quite useful, and I'm a big fan of positive side effects of work that I'm going to do anyway. And so we think that the explicit expression and the preservation of knowledge is really key. I mean, we all have been through and are all kind of experienced enough, I guess, to have been through legacy transformations, been involved in building some of those legacy systems. And so how do you just not recreate the same situation again? And so we think this explicit expression, like we do with business logic, could be applied more to the use cases. We think with the right training and the right tooling, we're not sure if we're there with the tooling yet. We think accessibility to the analyst and even to the sophisticated business users, because frankly, business users are a lot more digitally native now than they were when I started IT. When I started IT, they were essentially, a lot of them were technophobes, whereas now, because of their daily life, they're able to do more. And I think in some respects, they want to do more. If you can provide the guardrails and the acceleration, and more importantly, and I think that this is a real Achilles heel for the low code, no code that's targeting IT, that's not targeting IT. The fear around shadow IT, particularly with security and all those kinds of things, is how do you get a low code, no code that is accessible to business analysts and business users, but is well sanctioned by the IT. And this is why we think that separating those concerns and saying, here's the business representation, and here's the IT binding representation, and letting IT own that binding implementation if they want. Obviously, we could have out of the box implementations, and we do, but they can take ownership of those implementations. And that way we're able to help the business accelerate, but we're not competing with IT standards and trying to convince IT as to why they shouldn't be worried about this potential shadow IT. Another key element for me personally, having been around in IT long enough, is the fidelity of the implementation to the policy and procedure definition. That is a huge weakness in current systems, and that is why we have those long IT cycles. And invariably, I can't tell you how many times we've heard, well, what does the system do? And so we end up down at a programmer telling us what the system does. The programmer is essentially looking at a masterpiece through a straw and tells us this piece, specifies some changes. So not only is it the inaccuracy of the life cycle that we've given ourselves, but the fact that oftentimes the information that we've gotten from the impact analysis is incomplete. And it's only after we made the change. So you end up doing that cycle more than once, very, very often. So we think that that is a really key thing. And then there's a move, and a lot of people are interested in, well, let me see the dashboard, let me feed my ML models, let me do all of these kinds of things. And we think that this kind of micro use case, event-based situation has a high natural visibility of events, because what we find is that the obvious events at the edges of, somebody's underwritten a policy or somebody's bound a policy, those are obvious things. But what we find over time is we really need to get more subtle in terms of how many events we publish. And so the beauty of an event-based architecture, of course, is once the events are out there, people can use them. And so what we're moving towards is essentially a position where right now Sapiens has a bespoke business logic modeling environment. And we also have some other modeling environments for these concept models and the data, etc. What we're moving towards essentially is a more unified environment that will allow us to handle most of the situations that we find in systems. We'll be building through an agile framework and then essentially providing the knowledge as a service together with decisions. And these applications essentially become knowledge-driven applications. So what we've done now is we've essentially said knowledge and decision are at the top of the hierarchy, and they're directing services, UIs, applications. And so there really isn't the concept of a discrete application anymore. There's really the concept of a use case container that's representing to you, here's what you need for your particular use case. And then it's using decision and the technology binding models to essentially orchestrate between the services. And so you'll come to a particular screen and you'll say, well, this is what I want to do now. And that becomes a particular use case, and that occurs again. So the idea of a discrete end-to-end application, we think potentially is going away to more of this kind of environment. Now, we do find right now, what we're finding is there's obviously a tension around performance between a purely dynamic situation and a more static situation where all the code is hand-built and written. And so this is exactly why we have this design and execute, because what we're doing is at the time that you do a deployment, much like we do for our decision management tool, where when you deploy, what you're getting is a web service or Java code that at that point is static and performant. You're not invoking the model manager and doing meta model type work. We're doing that same thing with this particular framework to be able to get the performance. And so we do recognize that there's that design and execute separation, but that allows us to to get the performance and still be more agile than we are if we were in traditional IT. So I'm going to stop for questions. I know I've been hearing my computer digging, but I've been looking at the slideshow.
Yes, we have we do have a couple of questions in okay. Slack. So there was one from Denis and then one from Jan that sort of tied together. So Denis was asking if you've looked at the CMMN standard and its event condition action semantics. And then Jan said this looked a lot like CMMN plus DMN for dynamic processes, and how is it different? So I think there's kind of looking for some comparison with the CMMN standard.
Yeah, so there's absolutely a similarity there and an overlap. I'd also pull KDM into that environment, and we also come from a well, not when I say we, I should say I come from a company that was acquired by Sapiens recently, and we also have a history in the MDA world. And so essentially, we've taken a lot of pieces from those different things and kind of pulled it together, but we've tried to avoid, let me say, kind of heavy models that we find kind of turn business users off. You know, a knowledge graph is something that a business analyst is able to very quickly whiteboard, you know, just doing the and then game, you know, and then what happens, and then what happens, and then what question, and then, and so we find that there's also a very easy translation between if somebody has policy and documentation type things that are driven by, you know, questionnaires, knowledge gathering information. Those map very easily and can actually, in some cases, be reversed into here's a starting knowledge graph. And so I think there are overlaps there. We are kind of in early phases, and so we don't quite know where this is going from a notation point of view. This is what we have so far. It's pretty primitive. And we're also kind of keeping an eye on, you know, where is the rest of low code, no code going? And so that's kind of my answer at this point, is it's a wait and see, and there's definite overlap. But what we find is that the models don't all give us everything we need, and so we've come up with this kind of fairly abbreviated capability.
Right.
So, other questions? Let me
yeah. So Ron had a couple of different questions, and just to stick on the sort of standards side, he senses that you're creating a solution approach that diminishes the centrality of BPMN. And is this correct? And if so, like, what are your criticisms of BPMN?
Yeah, so essentially two things. What we're finding with BPMN is that it's mostly used as a specification only, and those specification only are there's wildly stylistic differences between one BPMN and another, and so we're finding that it's a specification only, but the devil's always in the details when it comes to implementing IT systems. And what we find is oftentimes when it's used as specification, because it's not actually going to be formally turned into code, is a lot of those details are left out. And so the analyst group feels like they're giving the IT group a great spec, and then the IT group essentially starts to redo some analysis. And so, you know, the fact if BPMN was always used, you know, through generation, I think that we'd be in a better position from that point of view. So it's really a practitioner perspective. And then the other criticism that I have of BPMN is that you consciously would have to kind of say, I want to make my use cases as essentially be bounded by events, because obviously within a BPMN, you know, you're going to have a start and an end, but you could have n number of events in between. And we think that events within event-driven architecture are things that are essentially, oftentimes events start to get us out of our use case, or they start to include other actors. And we feel that at that point, the BPMN is getting fairly large and unmanageable and not really composable. You know, there's this idea that you know, in the early days of BPMN, that we could have these composable processes, much like services, these composable kind of things. And what we found is there's very little composability going on. And in my mind, with my experience, I feel that the problem with composability is that when the scope of something gets too big, it becomes less composable. And so that's the two kind of items that you could well express these models as BPMN, and certainly the use cases are expressible as BPMN, but we would apply a strict kind of governance that says you can't emit events in the middle of a BPMN. If you feel like you need to emit an event, then you've essentially discovered another use case and you should break it.
Yeah, maybe not. It's Ron also had a question. He said, do you literally use the term use case with business people? And just speaking for myself, it's something that I would use with business analysts. I don't know if I would use it with like frontline business people, but what about you? And he's just kind of asking, what's the metaphor aimed at if you're talking about use cases? Yeah,
our biggest target is really the business analyst type people whose job it is to decompose the business into use cases.
Right.
And so our target is really business analysts, although we have had business users that kind of get it and come on board, but our target is really business analysts.
Right. Okay. He also asked if you strictly follow the SBVR meaning of concept model, or have you created your own meaning for concept model in this case?
Yeah, so what we've done is really combined the idea of concept modeling with a graph modeling approach. That essentially, so what we're doing is we're taking kind of everything that we've ever learned about relational modeling, and we're taking graph modeling and saying, it gives us a much more flexible representation. And then what we're doing is saying, yes, you have to define the concept. So the concept has to be fully defined to be on there, a la SVBR. But what we're doing then is saying, tell me exactly what the instances are going to look like. So we're really recording the metadata about the instance. So if you look at a concept model, for example, and we could look at one if we have time, there's a concept model called a question, and it describes what a question is, but the properties of a question are really data about the question. And so we've combined a graph meta model with a concept model.
Okay, that's all the questions that had come up now. So if you did want to do a short demo and show any of these things, I think that would be fine as well.
Sure, I could show a little something just to give you an idea of what an application like this looks like. Okay, so let's switch over to, and like I say, we're in the early stages of this. You guys are getting a preview of this. So what we have essentially is a couple of applications, and I will say that what you're looking at is built using what you're looking at. Okay, and so that's always fun. Okay, so what we have here is we have a particular, and I'm going to go down to a particular concept called a JES, and I'll describe what that is in a second. And so a JES for this particular customer, they are a customer that does corporate services in many domains. So think LegalZoom, that kind of thing. And so what they do is they say, for you to engage with me, you have to get a context called a JES. And that JES essentially is an acronym for jurisdiction, entity type, and service offering. And so we have the concept of a JES, which is in their domain, has meaning for them, may not have meaning for us, but for them it does. And so if we look at some of these things, so for example, if we say, we expand out a form, and I say, okay, well, let me have a look. And so what I've got is off of a particular context, I won't expand that further than this for the demo, but so we've got this concept of a jurisdiction, entity type, service offering combination gives us a JES. At that point, our use case says do a JES decision and process this particular form. So essentially what they have, if you imagine a very simple example of saying, I would like you, LegalZoom, to get me a hunting license. Well, how does that happen? Well, that depends. Where are you? And what kind of person are you? Are you a hunting club? Are you just an individual, et cetera, et cetera? And so all of those kinds of things essentially introduce a huge variability and optionality problem. If you think about the different services, because they go all the way from an example of a hunting license to helping Coca-Cola acquire some other companies, let's say. And so it's a massive set of services across a massive, and so you can imagine that this model explodes out significantly. And so what we do is we essentially, we model the concepts, and if we have a look at a concept, for example, we'll go and have a look at the question concept, is you'll see on the question that it basically says, here's the kinds of things that we have. So you can see it's saying, oh, do I need an answer? Do I have to have? And so very much metadata about the question, the answer and the question itself. Okay? And then essentially, once we're happy with our concept model, we publish this. So you'll see there's an action here that says, hey, let me go and publish this. So we've, prior to this, published this. And then what you're able to do is you're able to say, well, now that I've published the bespoke services, I would like to actually manage the instances. So now we're hydrating the model with our particular pieces. And so if I look at the example that I'm going to use is New York LLC formation. So now what we've actually got is particular instances of our concepts that are connected together. And so when I come with a particular use case, it's going to hit this particular part of the model. And then you'll see that some of these say JES decision, for example, and down on the questions, there's decisions as well. So those are the intra or inter use cases. And this particular application, so now we have an example of a knowledge-driven or decision-driven application. In this particular application, what their goal is to do an upsell. So they know, for example, that if you're going to form a limited liability corporation, which is a kind of company, in the state of New York, then you are required to publish the fact in the newspaper so that you can get objections. And so what they like to do is do an upsell. And so, of course, we model that as, oh, add on this tack on this use case to the use case you already have. And so what's happened here, so let me just go back because there's a subtlety here. What's happened here is that when I click on this menu, this system has gone to knowledge and says, hey, I need to interact with LegalZoom to do something. And they say, well, you've got to get a JES. Knowledge says you need a JES. And so the screen renders and says, well, here's what I need for a JES. And so everything that you see on the screen here, except for knowledge usage example, has come from knowledge. It said, these are the contexts that you have to give me. And you have to give me one of these, not just any one. So you have to give me one of these. And so I'll grab New York because I know that that data exists. I'll grab an LLC and I'll grab a formation. Now, when I grab this formation, the way that this particular screen is generated is it is going to go and execute those JES decisions. So it's gone off now to the decisioning engine and it said, I need to do some things. And what it said is, oh, would you like to add publishing? Okay, so that essentially knowledge has said, when they choose a JES, do these decisions. Now it could have come and said, would you like to add these 7 products? But in this particular instance, in this decision, we've only got 1. And you say, yes, I'd like to add this. And so recursively, then it goes back to knowledge and says, well, based on the fact that you said yes, now you've got New York Publishing. What it's also done is pulled out these forms. So some of this is knowledge driven and some of this is driven by decision. And so an example on decision of saying, if I say yes, I do have foreign ownership. So what happens if you have foreign ownership for certain criteria in the US is the application has to go for review by the Council for Foreign Investment in the US. And so here's an example of a decision that this application is not using. It's not recursively going back to knowledge, but it is going and saying, you need to submit for CFIUS review. Now that would be an example of one of those well-known directives that come out of a use case that say submit for CFIUS review. Somebody else would be listening for that event and that data, and they would go do their thing. It might be a batch job or whatever it is. So he's showing 2 examples. And so this application is essentially driven entirely by the knowledge graph and decision. And so what we're seeing is that the applications, whether they be processes, whether they be services, or they be more traditional handwritten applications, are essentially saying to knowledge, here's my current context, tell me what to do. And of course, knowledge is saying, well, today's the 23rd of September, 25th of September, you need to do this, because all of those instances are effective dated and versioned, etc. And so that's an idea of the work that we're doing to essentially augment decision try and get to a low code, no code world. Like I said, early days, these notations were recently kind of acquired. And so whether those notations stay the same or look the same, we haven't decided yet, but I wanted to give the group some insight as to how we're expanding beyond just business logic.
That's very interesting, Denzil. Is there any other questions or comments for Denzil at this time? Okay, I think that's all. So we will have a little bit of a break now while we switch over for the last